Hey everyone, ready for another deep dive? Today we're all about API security, and I've got a real treat for you. We're going to be picking the brain of Amin Abbaspour.
Sounds fun.
Right. He was a speaker at APIDays Hong Kong in 2023, and let me tell you, this guy doesn't just talk theory. He gets down to the nitty-gritty, He shared some really common mistakes that developers make when they're working with OAuth2.
And you know what? What's interesting about those mistakes is that they often seem small, but the implications for security can be massive.
Exactly. It's like, those tiny little cracks in a dam seem insignificant at first, but then, boom, you get a major breach. So whether you're building APIs or just trying to keep your systems, super secure, or even if you're just curious about how this whole OAuth2 thing actually works, this one's for you.
Absolutely.
Yeah.
So let's maybe start with one of the, I guess you could say, fundamental concepts, right? Access tokens.
Access tokens, okay.
One of the biggest mistakes that developers make is they try to peek inside them on the client side.
Ooh, yeah. It's so tempting, right? Like, what's in this magic token? But why is that such a no-no? Why shouldn't we be peeking?
Well, because access tokens are designed to be opaque to the client. Think of it like a tamper-proof envelope.
Okay.
Only the API, right, on the receiving end should be able to actually open it up and see what's inside.
So it's not just about hiding information. There's
Right.
like an architectural reason.
Exactly. By keeping those access tokens opaque, it allows the server side the flexibility to change the token structure. Maybe they want to update the encryption algorithms or even switch providers. And they can do all of that without breaking the client implementation.
Okay. So it's like a contract, right?
Exactly.
I just need to know, to show you the token, what's inside is your business.
Precisely. And this actually leads us to another common mistake. Confusing access tokens with ID tokens.
Oh, yes. The classic mix-up. I've definitely tripped over that one myself. So break it down for us. What's the difference?
Okay. So think of an ID token as your digital driver's license, right? It tells the application who you are. It provides some basic information about your identity. An access token, on the other hand, is like a key.
Okay.
It unlocks specific resources or actions.
So one is for identification.
Yes.
And one is for authorization.
You got it.
Got it. Okay.
Now, there's an interesting edge case where these two types of tokens can kind of work together. Let's imagine that you're trying to merge your Google login with a website's existing account system, for example.
Okay. So I would use my Google ID token to verify who I am, but then what?
Right. So that's where the magic happens. So you could potentially use your existing site credentials to then get an access token, essentially linking those two accounts together.
Oh, so it's like showing two forms of ID to prove I'm the same person, but in the digital world.
Exactly. And speaking of clever ways to enhance security, let's talk about PKCE, proof key for code exchange.
Yeah. Oh, yeah. That one always sounds a bit intimidating. So break it down for us. What's the big deal with PKCE?
Well, think of it as an extra layer of protection, right, during the authorization code flow. Essentially, it prevents attackers from, intercepting the authorization code and using it to impersonate a legitimate client.
So how does that work in practice? I'm curious.
So what happens is that the client generates a unique secret code, let's call it a code verifier, and then it creates a cryptographic hash of that code, and that becomes the code challenge.
Okay.
And this challenge is then sent to the authorization server along with the authorization request.
Okay, so I've sent the challenge, and then what? What happens next?
When the client later exchanges that authorization code for an access token, it also has to send that original code verifier.
Oh.
And then the authorization server will verify that the verifier actually matches the challenge that it received earlier, right? Ensuring that the request is truly coming from that intended client.
Wow, that is pretty clever. It's like a secret handshake that only the legitimate client knows.
Exactly. It's a really powerful way to prevent code interception attacks, especially in those public client environments, like mobile apps, for instance.
Oh, okay. That makes sense. So far, we've talked about, keeping access tokens opaque.
Mm-hmm.
We've talked about knowing the difference between access tokens and ID tokens. And now we're adding this extra layer of security with PKCE. So are there any other things that developers should be, really mindful of when it comes to keeping those tokens safe?
Well, one important thing is JWT claims validation.
Okay.
So, we're talking about those JSON web tokens that are often used to represent tokens in OAuth2.
Right, right. So not just using them, but actually checking them.
Exactly. It's not enough to just check the signature. You really have to dig deeper,
Oh,
right?
okay.
So, for example, you need to look at the ALG claim to make sure that the correct algorithm was actually used for signing. And also verify the audience, right, to ensure that the token is actually intended for your API.
So it's like checking not only the seal on the letter, but like, making sure it's addressed to the right place and
Yes.
has the correct return address.
Exactly, exactly. There are other claims as well, like for expiration time is for the issuer. All of these should be validated as well.
Right.
It's all about being thorough and closing those potential, security loopholes.
Yeah. Okay. I see that. So we've got these tokens. We're being, really careful about protecting them like they're Fort Knox, right? But what are the clients themselves? Are there different types of clients that we need to be thinking about?
Absolutely, absolutely. Understanding the difference between confidential and public clients is really fundamental to choosing the right OAuth2 flow and implementing those appropriate security measures.
Okay. So walk me through this. What makes a client confidential versus public?
Sure. So it all comes down to where the client application lives and its ability to store secrets securely.
Okay.
Right. So confidential clients, like web servers, they have control over their server-side environment, right? So they can securely store sensitive information like client secrets.
Got it.
Now, public clients, like, your mobile apps or those single-page applications, they run in environments where attackers could potentially get access to that information.
Oh, I see. So like treating a public client as confidential is like writing down your passwords on a sticky note and just like slapping it on your laptop.
Yeah, pretty much. It's just asking for trouble. You really need to choose the right OAuth2 flow based on the type of client that you're dealing with.
Right. Okay, that makes sense. Now this one throws me off a bit. Why shouldn't I just reuse client IDs for different applications or flows? Wouldn't that just make things simpler?
It might seem that way on the surface, but reusing those client IDs can actually create a lot of security vulnerabilities.
Oh, really? Okay.
And it also makes it a lot harder to manage and analyze your API usage. Think of it like this. If you have, one key for every door in your house,
Yeah.
if that one key gets compromised, then, all your doors are open.
Ah, so it's about compartmentalization. If I'm using separate client IDs, then I'm essentially creating these like separate security zones.
Exactly. If one client ID is compromised, the damage is limited to just that particular zone.
Oh, that's good.
Right. And it also makes it much easier to track which applications are using your API and how. You'll get those valuable insights into usage patterns and maybe even some potential anomalies.
Okay. So I'm seeing the value in keeping those things separate. So we've got these clients, we're being smart about their IDs and their access. But what about the cryptography behind all this? Are there any specific types of cryptography that are, better suited for OAuth2?
Yeah, you're thinking about asymmetric cryptography, right?
Yes.
Also known as public key cryptography.
Right.
And yes, it plays a crucial role in securing OAuth2 implementations.
So remind me, what makes asymmetric cryptography so special?
So unlike symmetric cryptography, which uses a single secret key for both encryption and decryption, asymmetric cryptography uses a pair of keys.
Right, right.
A public key for encryption and a private key for decryption.
Ah, okay. So it's like having like a mailbox with two slots, right?
Yeah.
One for sending mail, that's the public key, and one for receiving mail, the private key.
Yeah.
Anyone can drop a letter in that sending slot, but only the person with the key to the receiving slot can actually read the mail.
Perfect analogy.
Nice.
Yeah. So this basically means that you can share that public key freely without compromising the security of the private key, which is kept, nice and secret.
So how does this apply to OAuth2 specifically?
Well, we can actually use asymmetric cryptography for signing those JWTs and also for managing client secrets. So if your OAuth2 provider actually supports it, always opt for asymmetric keys and secrets. It adds a significant layer of security to your implementation.
Okay, yeah, I'm starting to see the power of this two-key system. So we've covered a lot already. We've talked about protecting those access tokens, understanding those client types, importance of those separate client IDs, and now the benefits of this asymmetric cryptography. Is there anything else on this OAuth2 security checklist that we should be thinking about?
Yeah, actually, let's talk about a common misconception about OAuth2 itself. Did you know that OAuth2 isn't actually meant for user authentication?
Wait, really?
Yeah.
I always thought, logging in with Google or Facebook, that was all OAuth2.
Right, and that's where a lot of people get confused. While OAuth2 is often involved in those login flows, its primary purpose is actually delegation.
Delegation.
Meaning it grants access to resources on your behalf.
Got it.
So if you need a secure user authentication, the right tool is actually OpenID Connect, or OIDC.
Oh, okay. So OIDC is like OAuth2's sophisticated cousin, but it specializes in verifying identities.
That's a great way to put it.
Awesome.
Yeah, OIDC is built on top of OAuth2, and it adds those features that are needed for secure authentication, like those ID tokens that we discussed before.
Right.
So it gives you a standardized way to verify the user's identity and get some basic profile information.
Okay, so OI2 handles access to stuff, and OIDC confirms that it's really me who's trying to access that stuff.
Precisely.
Got it. Now, what about those fine-grained permissions within an application? Can OAuth2 handle that that level of control?
It can handle some level of granularity, right?
Okay.
But those OAuth2 scopes, they're generally best suited for coarse-grained permissions, like giving an application access to your entire email inbox.
Got it.
But if you need more fine-grained control, like letting a user edit but not delete specific files, then you'll need a more specialized solution.
Okay, so trying to cram all that detail into OAuth2 scopes is probably not the best approach.
Exactly. It can lead to something we call token bloat.
Token bloat. Sounds almost as bad as code bloat.
It is.
Okay, so what's the issue with having, these large tokens floating around?
Well, those large tokens impact performance, right? API calls become a lot slower. They also increase that attack surface because you're transmitting more information, that could potentially be exposed.
Right.
And remember, minimizing the amount of sensitive data that you're sending around is always a good security practice.
Okay, that makes sense. Speaking of sensitive data, where should we be storing things like personally identifiable information, or PII?
That's a great question. PII belongs in those ID tokens,
Okay.
where it's a lot better protected and less likely to, be accidentally shared. Those access tokens, on the other hand, are meant to be shared more widely to grant access to resources, so including TII in them is a real privacy risk.
It's like keeping your passport in a safe at home versus carrying it around in your back pocket.
Exactly. You want to keep that sensitive information under much tighter control. Now, another common mistake is embedding API versions directly in access tokens.
Oh, okay. I wouldn't have thought of that one. Why does it matter where that information lives?
Well, think about what happens when you release a new version of your API.
Okay. Yeah.
Right. If that version is baked into the access token, all of those existing UFresh tokens become invalid, because they're tied to that old version.
Oh, no. So suddenly all my users are locked out.
Yeah.
They have to re-authenticate.
Precisely. It's a massive headache for everyone involved. So keep those API versions out of your access tokens.
Okay. All right. Lesson learned. Now, you mentioned dangerous callback URLs earlier.
Yeah.
Can you give me some specific examples of what to avoid?
Sure. So one common risk is allowing callbacks to subdomains that you don't actually control. So imagine a developer, accidentally leaves a callback URL pointing to a test environment, right? And it's hosted on a platform like Heroku, for example.
Yeah.
If that domain is later taken over by someone else, they could actually intercept authorization codes.
So it's like leaving a spare key under the doormat and just hoping that no one's going to notice it's there.
Exactly. Another risky practice is allowing callbacks to URLs that have open redirects.
Oh, okay.
This opens the door for attackers to manipulate that redirect flow and potentially steal sensitive information.
Wow. Okay. It's amazing how many seemingly small details can actually have these huge security implications. Are there any other important distinctions that we need to make when we're thinking about the different, players in the OAuth2 flows?
Absolutely. So understanding the difference between first-party and third-party clients is crucial for making informed security decisions.
Yeah. Break that down for me. What's the key difference there?
So first-party clients, those are applications that are developed within your own organization, like, a mobile app that accesses your company's API.
Okay.
Third-party clients, on the other hand, are external applications developed by someone else.
Right. So the level of trust is completely different.
Exactly. With first-party clients, you have more control, right? You can assume a certain level of trust.
Yeah.
However, with those third-party clients, user consent becomes really, really important.
Yeah, because you're granting an outsider access to potentially my data, right? My user's data.
Precisely. You need to be transparent about what data is being accessed, why it's needed, and for how long. And most importantly, you need to make sure that the user explicitly agrees to those terms.
Consent is key, especially when we're dealing with those third parties. All right, wow, we've covered so much already. I mean, from protecting access tokens to understanding different client types to the nuances of these callback URLs. It's been quite a journey already. So what other OAuth2 wisdom do you have to share?
Let's shift our focus a bit now to refresh tokens and how to keep them secure. Have you heard of rotating refresh tokens?
I've heard the term, but to be honest, I'm not really sure what it means. Tell me more.
Okay, so instead of using permanent refresh tokens that last forever, we can actually rotate them regularly, and this can help to detect and mitigate leaked tokens.
Okay. Walk me through how that works. I'm curious.
Sure. So each time a refresh token is actually used to obtain a new access token, the server issues a new refresh token and invalidates the old one.
Ah, so even if a token is leaked, it has a much shorter lifespan to do any damage.
Exactly. It's like changing your locks, periodically as an extra security measure.
Smart. So are there any other best practices when it comes to managing these refresh tokens?
Absolutely. Avoid long-lived refresh tokens. They increase the risk of compromise if they fall into the wrong hands.
Right. So it's like a ticking time bomb. The longer it exists, the bigger the potential for damage.
Precisely.
Okay, I'm getting the message. Short and sweet is the way to go for those refresh tokens. But how do we determine what's a reasonable lifespan for these things?
Well, it depends on your specific security requirements and the sensitivity of the data that's being accessed.
Go.
But as a general rule, shorter is usually better.
Got it. Keep them short and sweet. Now, what about access token lifetimes? How do we find the right balance there?
Well, that's where that Goldilocks principle comes into play, right?
Okay.
Not too short, not too long, just right.
Right.
Finding that sweet spot for those access token lifetimes involves weighing those trade-offs between, security and performance.
Okay, yeah, walk me through that. I'm intrigued.
Okay, so short-lived tokens, right? They enhance security because they limit that window of opportunity for attackers.
Got it.
But they also require more frequent token renewals, which can have an impact on performance and scalability.
Right. So longer-lived tokens are more convenient, but they're also riskier.
Exactly. You need to carefully consider those risks and benefits based on your application's specific needs and security requirements.
Right. So no easy answers there. It really depends on the situation.
Yeah.
All right. So we've talked about refresh tokens. We've talked about access tokens. What's next on our OAuth2 checklist?
Let's talk about stateless design. It's one of the key principles of OAuth2 and JWTs, and it plays a really, really crucial role in scalability and performance.
Okay, remind me, what does stateless design mean again?
Sure. So in a stateless system, each token contains all the information that's needed to validate itself.
Okay.
Meaning the server doesn't have to maintain any session state or remember anything about the token or the user.
So it's like each token is its own self-contained unit of information.
Precisely. And this eliminates the need for the server to actually, store and manage session data.
Got it.
Which simplifies the architecture, improves performance, and makes the system, much more scalable.
Okay, that makes sense, especially as the number of users and requests start to grow. But are there ever any situations where you might need to deviate from that principle, where you would introduce some stateful components?
Yeah, there are definitely some edge cases where those stateful components might be necessary, like, if you need to revoke tokens before they expire, for example.
Okay, yeah, that makes sense.
But in general, you should really strive to keep the system as stateless as possible.
Got it. Stateless is best, unless absolutely necessary. Any other parting advice before we wrap up this part of our deep dive?
Just one more thing. Avoid those unnecessary constraints on your API access. Don't limit access based on the client unless it's really essential for security.
So don't be too restrictive with who or what can actually use the API.
Exactly. Overly restrictive policies can make it harder to adapt to new use cases and integrate with other systems in the future. It's all about striking that balance between security and flexibility.
Right. We don't want to build ourselves into a corner with all these, overly rigid rules. So to sum it all up, we've talked about, refresh tokens, access tokens, the importance of that stateless design, and the dangers of those unnecessary constraints. So what other insights do you have in store for us for the next part of this OAuth2 exploration?
Well, let's maybe zoom out a bit and explore some broader API security principles that go beyond just the specifics of OAuth2.
Okay.
Are you ready to expand our horizons a bit?
Absolutely. Bring on the bigger picture of API security.
Awesome. So, we were talking about all those different pieces of OAuth2, but let's zoom in on one specific part. OAuth2 grants.
Grants, okay.
Yeah, they're the mechanisms that actually allow those clients to obtain authorization. And it's kind of interesting how OAuth2 has actually retired some grant types in its latest version.
Oh, really? I didn't realize that they had gotten rid of some.
Oh.
So which one's got the boot and why?
Okay, so the implicit grant and the resource owner password credentials grant, those were deemed insecure, and they've been replaced with more robust alternatives.
Okay. So what made those grants so risky? I'm curious.
Well, with the implicit grant, you had a much higher risk of token leakage.
Okay.
Because those access tokens were returned directly in the URL.
Oh, okay.
So they were vulnerable to interception. Imagine, sending your credit card number on a postcard instead of in a sealed envelope.
Yikes. That sounds pretty bad.
Yeah.
What about the resource owner password credentials grant? What was wrong with that one?
Well, that one essentially handed your username and password directly to the client.
Oh, no.
Which is a massive red flag from a security standpoint.
Right.
It's like giving someone a key to your house instead of just letting them borrow a cup of sugar.
Right. Yeah, definitely not a best practice. So what are the recommended alternatives now for modern applications?
Okay, so for most scenarios, the authorization code grant with PKCE is the way to go.
Right, that we were talking about earlier.
Exactly. It's much, much more secure.
Yeah.
And it provides better protection against a whole bunch of, attack vectors.
So it's like upgrading from that flimsy padlock to a high-tech security system.
Precisely. Now, this leads us to another common misconception, using OAuth2 for user authentication.
Wait, but isn't that what OAuth2 is all about? I mean, logging in with your Google or Facebook account, isn't that OAuth2?
That's where the lines get a little bit blurred, I guess.
Okay.
So remember, OAuth2 is primarily designed for delegation, meaning it grants access to resources on your behalf.
Right.
But if you need secure user authentication, OpenID Connect, you know that OIDC, that's the tool for the job.
Ah, okay. So OAuth2 is handling access to the cookies, and OIDC is checking to make sure you're allowed in the cookie jar in the first place.
Perfect analogy. Yeah, so OIDC builds on top of OAuth2, and it adds the necessary features for robust authentication, like those ID tokens that we talked about before.
Right. Okay.
Yeah, so OAuth2 manages that access, and OIDC verifies the identity.
Got it. Okay. Now, what about fine-grained authorization? Can OAuth2 handle that level of detail?
It can handle, some level of granularity.
Okay.
But those OAuth2 scopes are generally best suited for coarse-grained permissions, like giving an application access to your entire photo library.
Right.
But if you need more fine-grained control, like letting a user, edit but not delete specific files, then you'll need a more specialized solution.
Okay, so trying to cram all that detail into those OAuth2 scopes, not the best approach.
Exactly. It can lead to token bloat, which, as we discussed before, can negatively impact both performance and security.
Right. It's like trying to stuff a week's worth of clothes into a tiny carry-on bag. It's not going to work very efficiently.
Exactly.
Okay, so if OAuth2 isn't ideal for this really fine-grained authorization, what are the alternatives?
Well, there are dedicated fine-grained authorization solutions out there that are much better suited for handling those nuanced permissions. They can provide the flexibility and granularity you need without bloating those tokens.
Okay, so choosing the right tool for the job is really important in the API security world.
Absolutely.
All right, so we've talked about tokens, we've talked about grants, we've talked about different types of clients. What other, key considerations should developers really keep in mind, when they're building secure APIs with OAuth2?
One crucial aspect is understanding how to design and manage those refresh tokens securely. Those tokens that allow clients to obtain new access tokens without requiring the user to re-authenticate every time.
Right. So it's all about convenience and making that user experience nice and smooth. But they also introduce some potential security risks, don't they?
Exactly. If a refresh token is compromised, then an attacker could potentially gain long-term access to a user's resources, and that's why it's so essential to implement security measures like rotating those refresh tokens.
Or rotating refresh tokens. Okay.
Yeah.
Tell me a little bit more about that.
Sure. So it's a technique where each time a refresh token is used to obtain a new access token, the server will issue a new refresh token and invalidate that old one.
Okay.
That way, even if a token is leaked, its window of opportunity to do any damage is significantly reduced.
So it's like changing your passwords regularly to kind of limit the impact of a potential breach.
Exactly.
What are some other best practices for managing those refresh tokens?
Well, one important rule is to avoid those long-lived refresh tokens.
Okay.
The longer a refresh token remains valid, the greater the risk if it falls into the wrong hands.
Right. It's like leaving your front door unlocked.
Exactly.
The longer it stays open, the more chances someone has to just, wander in.
Exactly.
Okay. All right. Short and sweet is the way to go for these refresh tokens. But how do we determine, what that ideal lifespan should be?
Well, it depends on your specific security needs and the sensitivity of the data that's being accessed.
Okay. Yeah, that makes sense.
But a good rule of thumb is to strike a balance between that security and user convenience.
Okay.
Right? If you make that refresh token lifespan too short, users are going to be, constantly forced to re-authenticate, which can get pretty annoying.
Right. Nobody wants that. It's got to be that sweet spot.
Exactly.
Now, what about those access token lifetimes? How do we choose the right duration for those?
Yeah, that's another critical decision. You really need to weigh the trade-offs there between security and performance.
Mm-hmm.
So those short-lived access tokens, they provide better security because they limit the window of opportunity for attackers, right?
Yeah.
If there's a compromise.
Right.
But they also require more frequent token renewals, which can then impact performance.
So it's kind of like a tug of war between security and usability.
Exactly. Shorter tokens are more secure, but they can, lead to more overhead and potentially slower response times.
Right.
Longer tokens are more convenient, but then, they increase that risk if they are compromised.
All right. So again, it's about finding that right balance for your specific application.
Exactly.
No one-size-fits-all solution. We've covered a lot of ground on those tokens and how to manage them securely. What other important architectural considerations, I guess, should developers be aware of when it comes to OAuth 2?
One of the most important principles to understand is this concept of stateless design.
Okay.
This is a cornerstone of OAuth 2 and JWTs. And it plays a really crucial role in building scalable and performant API systems.
Okay. Remind me again why stateless design is so important.
Sure. So in a stateless system, each token actually contains all the information that's needed to validate itself.
Okay.
Meaning that the server doesn't have to maintain any session state or, remember anything about the token or the user.
Okay. So it's like each token is self-contained.
Precisely. And this eliminates the need for the server to actually store and manage session data, which, simplifies the architecture, reduces overhead, and makes the system much more scalable.
Yeah. I see how that would be, really beneficial as the number of users and requests grows. But are there ever scenarios where you might need stateful components?
Yeah, there are some exceptions, like needing to revoke tokens before they expire, for example.
Right.
But in general, you should really strive to keep the system as stateless as possible.
Got it. Stateless design is the gold standard, unless there's a really compelling reason to do something different. Any other parting words of wisdom before we wrap up this part of our deep dive?
Just one more thought: avoid imposing those unnecessary constraints on your API access.
Okay.
Don't limit access based on the client unless it's absolutely essential for security reasons.
So don't be too restrictive with who or what can use the API.
Exactly. Overly restrictive policies can make it harder to, adapt to new use cases and integrate with other systems in the future.
Right.
It's all about finding that right balance between security and flexibility.
Right. Yeah. We don't want to paint ourselves into a corner.
Mm.
So to sum it all up, we've delved into, those refresh and access tokens,
Yeah.
The importance of stateless design,
Mm-hmm.
and the perils of those unnecessary constraints. What other insights do you have in store for us in this final part of our OAuth2 exploration?
Well, let's zoom out even further now and explore some even broader API security principles that go beyond just the specifics of OAuth2.
Okay, I'm excited.
Awesome.
Okay, so we've really dug deep into the world of OAuth2, right? Everything from those access tokens and refresh tokens all the way to, why that stateless design is so important. But now I kind of want to zoom out a little bit, broaden the perspective. So what other API security considerations should developers be, really thinking about? What's on the radar?
One area that I think often gets overlooked is API schema validation.
Schema validation, okay.
Yeah, it's all about defining a clear contract for how your API should be used.
So it's like setting ground rules for how clients can talk to the API, right?
It's exactly. You're essentially creating this blueprint,
Something
that
around.
specifies the exact format of requests and responses, including the data types, the required fields, and any constraints.
So why is that so important from a security standpoint?
Well, by validating those incoming requests against the schema, you can prevent unexpected or potentially malicious data from actually reaching your backend systems.
Okay.
It's like having, a bouncer at the door.
Okay. Yes.
Checking those IDs, making sure that only, the authorized guests, the ones with the right credentials, get in.
So it's like an extra layer of protection there.
Exactly.
So schema validation, it's like the first line of defense, making sure the data is formatted correctly.
Mm-hmm.
What other security things should we be thinking about?
Another essential tool in your API security arsenal is rate limiting.
Rate limiting, okay.
Yeah, this helps to protect your API from abuse and those denial of service attacks by controlling the flow of requests.
So if someone tries to bombard my API with just a ton of requests,
Yeah.
rate limiting is going to be that traffic cop, slowing them down or even blocking them completely.
Exactly. It prevents those malicious actors from overwhelming your server.
Yeah.
And it ensures that those legitimate users can still access the API, without experiencing those performance issues.
Right, keeping things running smoothly. So it's all about maintaining that balance and protecting the API from getting, overloaded. Any other best practices we should be thinking about when it comes to the data that's coming in?
Input validation is absolutely crucial. Never trust data that's, coming from those external sources blindly.
Okay.
You always want to sanitize and validate all those inputs before processing them. And this is true no matter how, trustworthy that source might seem.
So even if the data passes that schema validation check,
Yeah.
we still need to scrutinize it, look at the actual content.
Absolutely. Schema validation is checking that structure, that format.
Okay.
But it's not necessarily, looking for malicious code or those unexpected characters that could potentially exploit, some vulnerabilities. Input validation is like, double checking the ingredients before you add them to your recipe. You don't want any surprises, ending up in that final dish.
Okay. I'm seeing a pattern here. It's all about those layers of protection, carefully, vetting everything that comes in. What else should we be doing to stay ahead of, those bad guys out there?
Security testing should be an ongoing process. It should be integrated into, every stage of that development life cycle. It's not something that you just do at the end as a final check.
So it's about finding and fixing those vulnerabilities, early and often.
Exactly. The earlier you catch them, the easier and less expensive they are to actually fix.
Yeah.
Think of it like, those regular health checkups.
Okay.
It's much better to detect and address those issues early on
Right.
than to wait until a major problem arises.
Right. Prevention is always better than the cure.
Yeah.
So what are some common types of security testing that are, specific to APIs?
Well, penetration testing is a pretty popular approach.
Okay.
And it involves, simulating real-world attacks
Okay.
to see how your API holds up under pressure.
So it's like, hiring an ethical hacker to try to break into your system and find those weak spots.
Exactly. You're essentially putting your API through its paces,
Okay.
identifying those vulnerabilities before those attackers can exploit them.
Smart. It's been really fascinating kind of exploring these different layers of API security. I mean, from those very specific details of OAuth2 to, these broader principles like schema validation, input validation, rate limiting and penetration testing. Any final words of wisdom before we wrap up this deep dive?
Well, remember that security is a journey, not a destination.
Ooh, I like that.
Technology is constantly evolving. New threats are emerging all the time.
Right.
So it's crucial to stay informed, right? Adapt to those changing landscapes and continually invest in learning and improving those security practices.
It's like staying in shape.
Yeah.
You can't just go to the gym once and expect to be fit forever.
Exactly.
It takes ongoing effort and dedication.
And it's also important to remember that security is everyone's responsibility. The developers, the operations teams, the security professionals, and even the users. We all play a role in keeping those APIs secure.
It's a team effort. Well, we certainly covered a lot of ground today, from those common OAuth2 pitfalls to the best practices for securing those tokens, managing those clients, and kind of broadening our perspective to include all of those essential API security principles like schema validation, rate limiting. What stands out to you as the most crucial takeaway for our listeners today?
For me, it's the importance of a proactive security mindset. Don't wait for something to go wrong before you actually start, thinking about security.
Right.
Build it in from the beginning, embrace those best practices, and really make security an integral part of that development process.
Absolutely. And never underestimate the power of ongoing learning. The world of API security is constantly changing, so staying curious, staying informed is key to staying ahead.
Well said. By understanding those nuances of OAuth2 and embracing that proactive security approach, we can create a more secure and trustworthy digital world.
That's a great note to end on. Thanks for joining us for this deep dive into the world of API security. Until next time, stay curious and stay secure.